In Shplait, when we write down a function like this one, polymorphic identity, we get back a simple type, A to A. Now, why does Shplait show this type and not show the forall on the outside? There's a good reason why taking this shortcut is justified. And it's connected to the idea that something with a forall type is not quite a function yet. It needs a type to specialize to. So whereas a function can be applied directly to a value, a polymorphic function has to be applied to a type first, and then it can be applied to a value. This distinction is important when we look more at type inference. For example, here's a function f which is looking for two arguments, first a value v and then a function h, and then it applies that value to the function. G down below is another function, and we use that to make a call to f. So we apply f first to the int 10 and then to the function g. Now, suppose we had to write out all the type applications in this program. Where would those go? They would go at the function call. F would need to be applied to two types, first for that value v, and then to go inside that function h. And g, similarly, inside of the call, g needs a type application. And that's because f is looking for a function, but g, before the application, is not quite yet a function. It's a polymorphic value. If we had a way of saying that f expects an h which has a forall type, then we would need to have a type application inside of f. Before we can do the application h of v, we would need to apply h to some type variable b that matches the argument value. Now, in this sort of language where h can have a forall type, we can go even further and get even fancier. Here we've got a function that takes a polymorphic argument g, and it uses g in two different ways. First, it applies g to a boolean, and then second, it applies g to an integer. This is neat, but it's a bit of a tricky place to be in, because if we wrote the same code, but without that type annotation for g, type inference would try to fill in that hole, and it would run into trouble. There's a mismatch now between the code that we can write and the code that we can infer types for. Shplait says that this program is just not allowed, and it's in good company here. The whole ML family of languages adopts the same restriction. Programs can't work directly with polymorphic values, so that means this function that takes in a g is not allowed. And this means that type inference has this nice consistency or smoothness property. Any types that you leave out of the program can be filled in by the type inferencer. This consistency property is the reason why we're justified in leaving out forall types. Because of the restriction, we know that every forall, if it appears at all, is going to appear at the beginning of a type. So there's no problem abbreviating a type like this one, forall alpha, forall beta, as just alpha arrow beta. There's no loss of information because there's no other place for those foralls to appear. One remark though, some languages, like Haskell, will allow you to write a forall type. In Haskell, you can write this type down and the program will type check, but if you leave the type off, then the program will not type check. Haskell won't infer a polymorphic type, but it will allow you to write them.